Okay, so you have you could easily see that this is working for symbolical variable and we in the last video we wrote a function to automatically solve the expression by parsing uh, like by deparsing the expression and feed it into the Rayakas API. I'm going to show you how complicated things can go. This is a this is a code block modified from my previous version of the code for mathematical modeling, and uh, from this one you can see I define each expressions for each variable, and then I pass those variable into an API. So these expressions are actually working to like feed the content of the expressions into other program, and you could do evaluation. So uh, the expression only gives you a W with respect to some variable, P is respect to some variable, C is with respect to some variable, but it doesn't calculate for you. So up to this stage, the status of P, if I put P here, it's still it's it would be a function with would be an expression with respect to R and C if I don't evaluate inside the API. Um, but when I do feed it into the computer algebraic system, it does the simplification and substitution for me. So it's pretty nice, and I could use I can print out the valuation of P. So actually it gets more complicated than that. I'll just try to rerun this one. Okay, so that's the full expression on P. Maybe that one got clipped. And I can calculate its derivative because we can extract the let's say we can extract the contents for P, and the computer algebraic system will know what content it is. Probably there will be some better solutions later. I can evaluate its second derivative, and then I can calculate the derivative. I could calculate when the derivative reaches zero symbolically. I mean, truly symbolically, because you are using characters, strings, and expressions and bodies of function to let the program know, right? To let the program know what will happen. So I will. So the solution is kind of hard to deal with. The solution. I mean, if you put out expression, there will be a funny bracket outside the solution, and it wouldn't really work. I my solution is to get it into the strings and then convert it to, you know, just clip out this part. Just delete the curly bracket and put double equal sign to single equal sign here, and I can get such expression. Oh, sorry, probably rerun this. Okay, and I get expression for the solution, and it's nothing different from. I mean, it's nothing different than the other part. It just this expression has T1 inside the bracket, but you know, think of expressions like characters. I mean, a string that describes your system, or think of expressions like a piece of your program itself. It doesn't matter. Like you know, it doesn't matter if you have T1 equals to something. It's just an operation. But what I did really interesting here is I could get rid of this. I will evaluate the expression. Now, if you look at this part, when I evaluate a solution expression, it actually gave me a value of T8. Okay, so T1 equals to 8. We didn't know that before this step. And watch what happens to the value when I evaluate dp dt. Well, basically nothing happens. Why? Because dp dt is expression without the assigning part. So dp dt is the just expression. Just give you a value of dp dt. I think that's good enough. If you want more, you could assign a value to it outside the evaluation sign, and I can calculate the second derivative of this. So it can actually get pretty much more complicated if you try to write a sophisticated problem like this, and you could always write some functions to do with those symbolical things. I mean, you give the program an expression, or you give the program some functions or some information to do with. It returns to you not just a numerical value, but also some other expressions for you to evaluate. So this could be really great. So let's use that idea to say write a program uh, to create a function. Like I could actually so that I could actually do this. I could have a function. So write a function is a function that takes in an expression, or let's just take in some characters. Just doing that fancy converting things enables you to generate a bunch of expressions out of expressions. Okay, so I probably have the name of the function. Maybe just fn name, fn body. Okay, and I will paste. Okay, I will use this thing. I'll use function name as my first argument, as my first bar. And when you create function, you when you create function, you create a function, and it's not really useful. Uh, and I probably have a function parameter here. For simplicity, I just assume this it only has one function parameter. Okay. And it's going to, have a function body. So probably a space, and I'm just assuming this is a one-line function body. Okay, and how we do this? We evaluate, not evaluate that, but we return another code block. Say parse text is this. So I created I just convert my string again into a expression. So you have to call that function, write a function. I want to write a function called f, and fn parameter is called x, fn body. Well, let's the minus x squared, just in case if just in case if other f of x duplicated with that. So it says unexpected this. Let's examine function this. Oh, okay. So parse this fn parameter. Actually, you should have a you should have a correct number of parentheses, and it works. But if you type here x, it's going to be the old x, which is incorrect. However, if I go evaluate, write a function this, so I'm evaluating a function output, which is an expression that creates me a function, and I go to and I create f, and then not magically it does create a function for you. That's how metaprogramming or maybe it just playing with the expression enables you to do. You could create very complicated programs without involving for loops because you can almost always handle blocks of programs as characters, and it enables you more, and it gives you more capability than just writing functions, because you could now write functions that changes function, that derives function, that solves symbolical expressions and creates symbolical expression, and probably construct more complicated functions with more with some simple function as inputs, and that's the key idea of making it abstract and flexible. I hope that you find this useful, and thanks for watching this video.